In this video, we are talking about the geometric distribution, and we're considering example 13, which says you need to find a store that carries a special printer ink. You know that of the stores that carry printer ink, 10% of them carry the special ink that you need. You randomly call each store until one has the ink you need. You wish to know the probability that you need to contact 4 stores. So the first question we need to answer is, why is this a geometric problem? Well, that means that we need to go through the characteristics of a geometric distribution. So the first characteristic is that you're considering Bernoulli trials. So that means you have 2 possible options for every trial that occurs. There are 2 options. But the difference here between a binomial distribution and a geometric distribution is that we're just going to keep going until we eventually get to a success. With a binomial, you have a specific number of trials that you do, no matter what the results of each trial is. With geometric, you don't have a specific number. So, in this case, we are going to call each store until you find one that has the ink you need. So, we call stores until we find what we need. So that's our success. Each time we call, there are 2 options. That the store has the ink, which is our success, or the store does not have the ink, which is our failure. And every single store has a 10% chance of carrying the ink. So the probability of success or failure is the same at every store. Which in this case, 1 store is 1 trial. So that's exactly what we need for a geometric problem. So again, the main difference, really the significant difference between a geometric distribution and a binomial distribution is that we keep going until we find what we need, until we get a success. So there is no specific number of trials that are going to be completed. Whereas with binomial, you have a specific number of trials. So that's the main thing that you need to check on in descriptions of problems. Do you have a specific number of trials or do you not? If you do have a specific number, it's a binomial. If you do not have a specific number, it's geometric. So let's continue on then with this example. X equals, well, how would we define our random variable according to a geometric random variable? The generic definition of a geometric random variable is the number of independent trials until the first success. So in this case then, X is going to be the number of calls, since those are our trials, until a store has the ink, the special ink, because that's our success. So what values does X take on? Well, it's possible that we stop after 1 call. Notice it's not possible for X to take on 0 because we have to actually call something in order to get a success. So X could be 1, it could be 2 or 3 or so on and so forth until however many total calls we do, but we don't have an end here. Since we don't have a specific number of trials, we don't have an end. So X can take on 1, 2, 3, and so on. What are P and Q? Well, P is the probability of success. It's the chance that a store will carry the correct ink, but we know that 10% do. So P, which is the probability of success, which in this case is the probability that a store has the ink, the special ink, that's going to be 0.1. And just like with the binomial, P and Q, when you add them together, are equal to 1. So we can get Q by subtracting P from 1. So we get 0.9. And that's our probability of failure, if you recall. Okay, what is the distribution for x? Well, we've already talked about the fact that it's geometric. We've defined x in a certain way, that it is a geometric random variable. So we are going to say that x is a geometric random variable with probability 0.1. Probability of success being 0.1. And that is all we need for a geometric distribution. Now, the problem says you wish to know the probability that you need to contact 4 stores. So the probability question is probability that x is equal to 4. You need to contact 4 stores, not 4 or less, but just 4 stores. So the probability that x is equal to 4. So then, as a follow-up, how would you write the probability that you need to contact at most 4 stores? That's a little bit different than what was originally described. At most 4 stores means you could contact 4 stores or 3 stores or 2 stores or 1 store. So that's the same thing as the probability that x is less than or equal to 4. And that wraps up our solution for example 13.